Hello everyone, in this section we'll introduce FVS training, 3D component. This section will give you a detailed introduction to the types, function and application of 3D components. Part 1, 3D component type. 3D components have three types, including 3D city scene component, custom 3D scene component and Unity component. After the user uploads the GeoJSON file, 3D City will automatically identify and parse the geographic feature elements in the GeoJSON file and then start to build a grid model based on the latitude and longitude point information of the feature and attach the default style material and finally render it out to quickly build a 3D digital city. It is suitable for a wide range of urban architectural scenes. It also supports the import of custom models. Custom 3D Scene component allows you to generate empty scenes, upload GLB model files, and construct 3D custom scenes through data layers and events. Custom 3D Scene component can achieve more rich effects and are often used in scenarios such as building smart parks and smart devices. Next, we'll introduce Part 2, 3D City Scene component. 3D City Scene component need to prepare GeoJSON files in advance. GeoJSON is a format that encodes various geographic data structures. The 3D City component automatically recognizes and parses geographic elements, currently supported elements including buildings, grasslands, rivers, and roads. Then the component constructs a grid model with default styles and materials based on the element's latitude and longitude, and finally renders the model, making it quick to construct a 3D digital city. For details about GeoJSON files and their access methods, you can search on Google. Here we use an example to show how to create 3D city scene in a dashboard. Create a new FVS visualization dashboard. Click the 3D icon and click 3D city scene to add a 3D city scene component to the canvas. In one page, only one 3D component of the same type can be added. For example, if you now add a 3D city scene component to page 1 again, you will be prompted that the addition failed and you can only add one 3D city scene component each page. The same is true for the other two 3D components. Click Edit Component to go to the component editing page. The first time you enter the editor, you need to generate new scene or import existing scene. If you choose to generate new scene, you need to upload the prepared GeoJSON file. Import existing scene, that is, a 3D city scene already made by someone else, exported for importing here. Here we choose to generate a new scene and upload a GeoJSON file for the example region. The system first checks whether the file can be compiled when you upload it. If it is, the file can be uploaded. If not, a prompt pops up indicating that the GeoJSON file cannot be compiled. You need to reselect a file and upload it. Click Generate Scene, and then the GeoJSON file size and data will be detected. More details can be viewed in the document. We provide example data from the network. There are some non-compliant data. Click Continue Generating. Now we successfully generate model scene. First look at the model configuration panel. The model list shows the building, street, water system, grassland models generated by the auto recognition. Models with name attributes in the GeoJSON file can be recognized as specific name models. Failure to identify is uniformly classified as other. It also supports adding custom model. The custom model and the models in GLB format, which is supported to be added in custom 3D scene component, can be learned in the 3D custom scene components section. Here is a demo. Click Add Custom Model, then Upload Model. You need to pre-process the model when uploading. Here we just leave it as the default settings. Select the model to load the scene. After loading the scene, the model is too big compared with the 3D city scene. Select the model and modify the scale to 0.01. You can move, rotate, and scale the model with the gizmo tool, and then fine-tune it according to the situation. The model also supports the configuration of various attributes. It should be noted that some of the settings and operations supported by the customized model, but it may not be supported by the automatically generated model of the 3D city, such as copying and pasting, moving, scaling model, etc. the Manage Model animation in the upper right corner of the model list is only for custom models with self-animated effects. The 3D City model supports deleting, modifying the name, showing or hiding, setting the model style, building material, color, and other effects. You can adjust the view angle with one click through the 3 preset views. Left-click and drag to rotate viewing angle. Right-click and drag to pan, scale, or lower viewing angle. Scroll mouse to zoom in or out viewing angle. New versions also support rotating the viewing angle by clicking the keyboard up and down, left and right keys, and panning the horizontal plane with the keyboard W, A, S, D. The 3D City Scene component supports adding 4 types of data layers: point data layer, line data layer, column data layer, and model data layer. After adding a data layer and binding data, you can add layer update and left-click events to the layer, achieving effects such as model data display and linkage interaction. Data layers will be introduced in detail in another subsection. Let's learn about the Scene Configuration panel. 3D City Scene overall style includes sci-fi style and simple. The overall style change will override all previously configured styles. The environment supports setting the ground background. The default is monochrome. The GI's base map is the background with geographic information data. You can set the building height. You can enable the particle effects. When you enable the effect that it displays a snowflake-like effect in the city scene. Shockwave can be added. It is a kind of effect of spreading ripples around with some point as the center. If you enable soaring lines, it displays light pillars continuously rising from the ground to the sky in the scene. The camera can set some basic properties of the viewing angle, such as the scale setting and the vertical angle range. Enable field depth effect. It will display that clear scene within the focus distance and blur scene beyond the distance. Enable viewing angle change. It allows you to achieve the automatic 360-degree rotation effect of the 3D City model, with the rotation speed being configurable. It also allows you add camera viewing angle and roaming animation. More details can be viewed in the help documentation. The setting items in the image are optimization operations for all models. In addition, the various effects added to the scene may cause the scene editing to lag due to rendering. At this time, you can enable the smooth render in the toolbar to improve the editing performance of the scene. After smooth render is enabled, some configuration items do not take effect in the scene editing page, but still take effect in preview mode. For more details, you can view the help documentation. After finishing the scene setting, we can export the current scene. Then we can import it when we create a new 3D City Scene component. After finishing the scene setting, we can also replace scene data. The scene data replacement neither affects the configured scene attributes, nor affects the uploaded custom models. Finally, back to Visualization Dashboard, go back to the canvas, select the 3D City. The first button in the upper right corner of the component can be re-entered into the scene editing page, and the second button can be adjusted in the canvas directly to adjust the viewing angle. Click Finish to save successfully after the adjustment is completed. Then we'll introduce Part 3, Custom 3D Scene Component. Custom 3D Scene Component need to prepare GLB files in advance. For scenes that do not require high level of modeling reproduction and detail, you can model by yourself, but FVS only supports model files in GLB format. The other formats need to be converted for use. For more information about Custom 3D Model, please consult the documentation. Create a new FVS Visualization Dashboard. Click the 3D icon and click Custom 3D Scene to add a custom 3D scene component to the canvas. In one page, only one 3D component of the same type can be added. For example, if you now add a custom 3D scene component to page 1 again, you will be prompted that the addition failed and you can only add one custom 3D scene component each page. The same is true for the other two 3D components. Click Edit Component to go to the component editing page. The first time you enter the editor, you need to generate empty scene or import existing scene. If you choose to generate empty scene, you need to select one style to generate scene. Import existing scene, that is, a custom 3D scene already made by someone else, exported for importing here. Here we choose to generate an empty scene. After entering scene editing page, we need to upload model first. Click Model Configuration pane, click Add Model, open the Model Management pop-up box, click Upload Model, select the prepared GLB model file, support multi-select for batch upload. When uploading models, you need to set the data preprocessing and style preprocessing. Data preprocessing can adjust the display level upper limit of the model, that is, the lowest level at which the model imported into FVS can display and configure data. Assume that buildings are level 0, floors are level 1, and rooms are level 2. When the display level upper limit is equal to 1, you can only configure data, labels, and interaction events for buildings and floors, not rooms. When the display hierarchy upper limit is equal to 2, then rooms can be configured. Perform operations carefully because the data preprocessing settings cannot be undone and remodified. Style preprocessing can enable wireframe style, a visual effect with a technological feel. The style preprocessing can be modified twice, with the option to skip it when uploading the model for the first time. After the model is uploaded, if you hover the mouse over the model thumbnail, the Preprocess Model button appears. Click the button and the setting box pops up. You can make modifications in style preprocessing, while data preprocessing is gray and cannot be modified. Hover your mouse over the model thumbnail and you can click the pop-up icon to delete the model. Select a model and you can click Delete Model to delete the model. It also supports batch deletion. Click Load into Scene to add the model to the scene. If a model has been used in the scene and you click the deletion button, a prompt box pops up. After the model is loaded into the scene, the model management page is not closed automatically, you need to close it by yourself. You can already see the loaded models in the model list. Click Add Model Object to open the model management interface again. You can view the model information and perform a fuzzy search in the search box to quickly find models by entering relevant keywords. Back to the scene editing page, we learn about the adjustment of scene viewing angle. Like 3D City Scene component, you can adjust the view angle with one click through the 3 preset views. Left-click and drag to rotate viewing angle. Right-click and drag to pan, scale, or lower viewing angle. Scroll mouse to zoom in or out viewing angle. New versions also support rotating the viewing angle by clicking the keyboard up and down, left and right keys, and panning the horizontal plane with the keyboard W, A, S, D. Then we learn about operations on models in a scene. We can select a model in the model list. The selected model is highlighted. And the gizmo tool appears, with which you can move, rotate, and scale the model object. Drag the square in the middle of the coordinate system and you can freely move the model on the XZ plane. Hover over the circles and you can move the mouse to rotate the model after the circle color changes. Hover over the small squares on the X, Y, and Z axes and you can drag the square to scale the model in the corresponding direction after the square color changes. If fixed ratio and scale is ticked in the right property panel, the length, width, and height are scaled proportionally and simultaneously. Else, the length, width, and height are scaled individually. Hover over the arrow of the X, Y, and Z axes, and you can drag the arrow to move the model along the corresponding direction after the arrow color changes. Undo and redo only apply to moving, rotating, and scaling the model. We can also select a model on the scene editing page. The selected model is highlighted. Click Deselect on the top toolbar or click areas outside the model to deselect it. On the scene editing page, we can press and hold the Shift key and the left mouse button to box select multiple. In the model list, we can press the hold the Control key and click Models to select multiple models or deselect models. Hover over the model name in the model list, you can do operations such as show, hide, focus, copy, rename, delete, etc. Click Hide to display or hide the model. Click Focus to switch to the default viewing angle of the model. Click Copy to copy the model. Click Rename to rename the model. Click Delete to delete the model. You can use Ctrl-C and Ctrl-V shortcut keys to copy and paste the model. After copy and paste operations, the pasted model is placed in the same position as the original model and selected by default. You can manually adjust its position. The parent model also supports setting the model style, animation, and reflection effects. Model style can be set to wireframe style. If the wireframe style is not enabled when uploading the model, you can directly enter the style preprocessing to set it here. Add wireframe animation to realize the animation process of switching from default style to wireframe style. You can check the details in the document. After adding wireframe animation, you can enable the animation in Model Animation Management, and you can also add the animation effect that comes with the model itself in Model Animation Management. For example, now we currently add a model with an animation effect. You can see the model building has an animation effect when it is turned on. Model animation is also supported to be triggered by click events of other components. Enable environment reflection. The reflection of the model appears on the ground surface. Enabling reflections can provide better visual effects but may reduce performance. It is turned off by default. Below, we will learn about the data layers of the custom 3D scene component, which only supports adding model data layers. After adding a data layer and binding data, you can add after data update and click events to the layer, achieving effects such as model data display and linkage interaction. Data layers will be introduced in detail in another subsection. Let's learn about the Scene Configuration panel. Custom 3D Scene overall style includes Live View and Sci-Fi style. The overall style change will override all previously configured styles. Environment configuration items of 3D Custom Scene Component are more than 3D City Scene Component. The camera can set some basic properties of the viewing angle, such as the scale setting and the vertical angle range. Enable Field Depth Effect. It will display that clear scene within the focus distance and blur scene beyond the distance. Enable Viewing Angle Change. It allows you to achieve the automatic 360-degree rotation effect of the custom 3D model, with the rotation speed being configurable. It also allows you add camera viewing angle and roaming animation. The setting items in the image are optimization operations for all models. In addition, the various effects added to the scene may cause the scene editing to lag due to rendering. At this time, you can enable the Smooth Render in the toolbar to improve the editing performance of the scene. After Smooth Render is enabled, some configuration items do not take effect in the scene editing page, but still take effect in preview mode. For more details, you can view the help documentation. After finishing the scene setting, we can export the current scene. Then we can import it when we create a new custom 3D scene component. Finally, back to Visualization Dashboard, go back to the canvas, select the Custom 3D. The first button in the upper right corner of the component can be re-entered into the scene editing page, and the second button can be adjusted in the canvas directly to adjust the viewing angle. Click Finish to save successfully after the adjustment is completed. Then we'll learn about Part 4, Data Layer in 3D Scene Components. The 3D City Scene component and the custom 3D Scene component data layer function is the same. The difference is only that the 3D City Scene supports adding 4 kinds of data layers: point data layer, line data layer, column data layer, and model data layer, while the 3D Custom Scene only supports adding 1 kind of data layer, that is, the model data layer in the 3D City Scene. Here we will use the 3D City Scene component to add a custom model as an example to explain the function of data layers. Create a new visualization dashboard and add a 3D City Scene component to the canvas. Edit the component, generate a new scene and upload the prepared GeoJSON file. After generating the scene, we first add the custom model. Load the scene after uploading the model. Adjust the model scale setting. Adjust the model to the right position. Modify the model name to Fan Run Office Building. Next we click on the Data Layers panel, click Add Data Layer. First we add a point data layer, enter the Data Layer Settings panel. You can modify the layer name, bind the dataset, set the point style. The fields to be bound to the dataset include longitude, latitude, name and content. The content supports adding multiple fields. Here longitude and latitude are the key fields, and the data layer can only be built correctly if the longitude and latitude are correct. Then we need a dataset containing these fields. You can create a new dataset. I have prepared the data here in advance. The point style supports setting 4 effects, and you can modify the color and radius ratio. A halo appears on the ground where a point is located. You can enable or disable it, and you can modify its color and radius. The light portal appears when you hover the mouse over a position. You can modify its color. The height from ground is the height between the point and the ground. Halo and light portal use fixed ground height display. Click OK after the settings are completed. The point data layer is added successfully. Add another column data layer. The content of the column data layer dataset fields and the point data layer dataset fields are the same, just bind the same information. You can modify the color, column width, and column height. The halo and light portal effects are identical to the point data layer. Click OK after the settings are completed to add it successfully. Let's hide this column data layer and add a line data layer. The line data layer only supports binding the latitude and longitude of the line starting point and the end of line. The line starting point and the end of line support multiple different latitude and longitude, do not support adding the rest of the content, generally can be combined with other data layers to show together. Line is an animation effect that flows from the starting point to the end of the line, and supports modifying the color and opacity of the line. Inflow and outflow points can be set to the effect of halo and light portal. Click OK after the settings are completed to add it successfully. At this time we see the point data layer combined with the line data layer effect. Hide the point data layer, only the line data layer effect. Next we add a model data layer. In the point data layer, line data layer, column data layer dataset key field is the location of the latitude and longitude. In the model data layer dataset key field is the model name. The field name can be set arbitrarily, but the dataset field selected for model name on the data layer setting panel of model data layer must be the same as the model name. For example, the values we have here correspond one-to-one with these names in the model list, and the same rule applies to the custom models in the custom 3D scene component. There are no other style settings for model data layer model, just bind the dataset and click OK. So how to tell if the model data layer is bound correctly? This is where we can add events to see. There are two types of events, layer update event and click event. If the layer update event is combined with the monitoring refresh of the component, it is possible to realize that the content of the component can be updated immediately after the data update, but if the monitoring refresh is not turned on, the effect after the initialization of the component will be presented. Layer update event include data label and data alert. A data layer only supports one data label event. We add a data label to the model data layer. You can customize data label names and select default in content. If you select custom in content, you can set the format of a field and click edit custom content and select data fields or enter the text in the rich text editing pop-up box. At this time, you can set items including the font, color, and position of the label. We can also set the display form of the label. When visible is selected, the label will always be displayed on the page. When hover is selected, the label will only be displayed when you hover the mouse over the data layer during the template preview. All the text constitutes the content. The distance from the content to the border is called the content margin. That is to say, the size of the border background changes with the content, but the content margin remains unchanged. We can set the overall zoom ratio of the label. Border background's default value is resource center. The setting method is the same as that of the component border background setting item. You can select None, Color, Resource Center, or Custom Upload from the drop-down list of border background. After the setting is finished, click OK to see the label effect. Multiple data alerts can be added to a data layer so that different alert messages are displayed when specific execution conditions are met. Let's add a data alert to the model data layer. Click Execution Condition Setting to enter the condition setting page. Then click Add Condition to add and edit the condition content. The content bound to the current data layer can be selected as the alert object. In the dataset, the model content field is Emergencies, which has two values, normal and abnormal. Here we set the warning condition that the unexpected event is equal to the string abnormal. When multiple conditions need to be met at the same time, we can set relationships between conditions and combining conditions. Hold down the Shift key to select multiple conditions, and you can combine or delete them. After setting the condition, we can set the style of the alert content when the condition is met. After the setting is completed, we can see the corresponding effect. Point data layer and column data layer also support layer update event. The usage is the same. However, the line data layer does not support adding layer update event. Click event supports 4 kinds of interactive events, which are the same as the interactive events of 2D components. Click event are supported by these kinds of data layers, the usage of the same. You can go to the interactive event chapter to learn. Here we will not explain. Then we introduce part 5, viewing angle change application and roaming path in 3D scenes. When previewing a 3D scene demo, you will sometimes encounter the following scene. 1. Click on the model. You can switch to a close-up view of the model. 2. Hope that the viewpoint changes in accordance with the prescribed route to achieve the scene roaming effect. Next, we use a simple template to give you an introduction to the camera view feature. This course content is based on the FVS version 3.1.0 plugin to explain the camera functions of the 3D City Scene component and the custom 3D Scene component are the same, and the custom 3D Scene component is used here for explanation. Select the component and click Edit Component to enter the scene editing interface. In the previous lessons, we have learned the rotation, panning and zooming of the scene viewing angle. If you are not clear about it, you can check it through the instructions. In the upper right corner of the scene, there are viewing angle parameters displayed, including camera coordinates and viewpoint coordinates. The coordinate values are changed in real time when the viewpoint is adjusted. We can copy and paste to replace the viewing angle parameters. Now I copy the current viewing angle, adjust it, and click Paste to replace, then we switch to the copied viewing angle. Click to the camera configuration panel of the scene. The zoom distance of the viewing angle refers to the distance between the camera and the viewing angle. It supports setting the closest and farthest distances, which indicate the degree of zoom. The farthest distance needs to be greater than the closest distance, and the greater the difference between the two values, the greater the zoomable range. For example, if the closest distance is 39.7, you can't scale to this extent. Turn down the closest distance to continue scaling. Vertical angle refers to the angle between the line of sight and the ground, and supports setting the maximum angle and minimum angle, which indicates the range that the line of sight can be rotated in the y-axis direction. The maximum angle should be greater than the minimum angle, and the greater the difference between the two values, the greater the range of rotation of the line of sight in the y-axis direction. For example, if the minimum angle is now plus 60, rotation to the ground will not be possible. Adjust the minimum angle to negative, then you can rotate to the range below the ground. Here we select the model and move it down some distance to observe the effect. From the ground the model is partially hidden, rotate it below the ground and you can see the hidden part. Back to the camera configuration panel, look at the field depth effect. Enable field depth effect, it will display that clear scene within the focus distance and blur scene beyond the distance. Enable viewing angle change, it allows you to achieve the automatic 360-degree rotation effect of the 3D scene, with the rotation speed being configurable. Enable viewing angle change does not affect other operations that adjust the scene's perspective. These two functions only support simple settings in the scene, so we won't go into details here. Here we explain the camera view. There are two main application scenarios for the camera viewing angle. One is that it can be bound to the model, and when previewing, you can click on the model to switch the viewing angle. The second is as a public viewing angle, which can be used in the editing interface when you need to quickly switch the viewing angle of the scene. Click Add Current Viewing Angle to bring up the viewing angle setting panel. You can modify the viewing angle name. The coordinate value of the viewing angle parameter is the current viewing angle in the scene, which is consistent with the value in the upper right corner of the scene. At this time, you can directly adjust the viewing angle in the scene. The value in the settings panel changes in real time. Adjusting the coordinates in the settings panel allows you to fine-tune the viewing angle, and the position of the viewing angle in the scene changes accordingly. It should be noted that adjusting the viewing angle in the scene is equivalent to changing the viewing angle of the scene directly. After clicking OK or Cancel to exit the viewing angle setting, the adjusted viewing angle will be maintained in the scene. When you adjust the coordinates in the settings panel and click OK or Cancel to exit the viewing angle settings, the scene keeps the same viewing angle as before the adjustment. The same goes for the Paste to Replace button in the viewing angle settings panel. For example, copy a viewing angle, then adjust to another viewing angle, add the current viewing angle, click Paste to Replace. After exiting, the scene's viewing angle returns to the viewing angle before the Paste to Replace. Let's learn how to bind models to viewing angles. The bound model can be any model in the scene. A viewing angle can be bound to multiple models, but a model can only be bound to one viewing angle. For example, if the current viewing angle is bound to building 1, bind the same building 1 to another viewing angle, then go back to the first viewing angle. You can see that the binding of viewing angle 1 has been cancelled. After adding multiple viewing angles, click the viewing angle in the viewing angle list, and the left scene will switch to the corresponding viewing angle. It supports re-entering the viewing angle to edit or delete the viewing angles. There is an associated logo at the bottom right corner of the icon of the bound model to distinguish it. Note that in the 3D City component, the bound model only supports customized model, and the model automatically generated by GeoJSON is not included in the selection. Then we learn about roaming path in 3D scenes. The roaming path is formed by adding multiple viewing angles and then setting the flight or dwell time according to the roaming mode to form a roaming animation. Click Add Roaming Path to enter the Roaming Path Settings panel, which supports modifying the path name, roaming mode, and adding current viewing angle. To add a viewing angle, you need to adjust the viewing angle on the left side of the scene and then click Add Current Viewing Angle to add the current viewing angle to the list. Adjust the next viewing angle, click Add Current Viewing Angle again, and so on to form a path. When the viewing angle is selected, the camera coordinates of the current viewing angle in the 3D scene are displayed at the bottom of the list. When a viewing angle is selected, the scene shows the position of the viewing angle. Drag and drop to change the order of viewing angles in the list, delete viewing angles, and rename viewing angles are supported. If you want to change the camera coordinates of the viewing angle, you need to adjust the scene on the left side and then click the Update Parameter button on the right side to update it. Dwell time is the time that the viewing angle stays after reaching it during the roaming animation. Viewing angles also support setting the flight time when custom roaming mode selected. Flight time specifies the flight time from the current viewing angle to the next one. When you have finished setting the roaming path viewing angles, click Finish to return to the camera configuration panel. You can add multiple roaming paths and edit, preview, delete roaming path in the roaming path list. Preview allows you to view the roaming animation effect on the current 3D scene editing page. During the preview, you can click Exit Preview or press the shortcut key Escape to stop the animation playback. You can press the spacebar to pause/resume the animation playback. If you click anywhere on the designer page other than the Exit Preview button during preview, a prompt saying Exit the roaming animation preview before performing other operations will be displayed, as shown in the following figure. If you exit the preview or end the roaming animation midway, the scene will stay in the current viewing angle. After setting up the roaming position in the scene, to play the roaming animation during preview, you need to realize it through interactive events. Go back to the visualization panel and add a title component with the title Enable Roaming. Add a click interaction event to the title component and select the 3D roaming animation. Customize the event name, and the trigger object can be selected as the 3D component of the current pagination or the 3D component of the background page. Here, the 3D component name has a page prefix on the original name, which is easy to distinguish. Trigger roaming to select the roaming path. If you add more than one roaming path, it will be played sequentially. Click OK to save the template and click Preview to view the effect. Click the title of the preview page. Instantly triggered roaming animation, but in the template preview, does not support shortcut keys for roaming animation. Pause, continue or exit. You can only wait for the end of the animation itself or through the JavaScript interface. Code details can be viewed in the help documentation. Copy the code in the help documentation, add the title component in the designer. The title content is pause roaming. Add a click interaction event to the title component, choose JavaScript event. Paste the code here and change the component name to the name of the current 3D component. After setting this up, copy and paste this title component, modify the parameters in the interface, pause, continue, exit. After finishing the setting, click Preview to see the effect. In some cases, the user wants the roaming animation to be enabled automatically when the template is initialized for preview, which can be achieved by using the interface to enable the roaming animation in the event after page load in conjunction with the delay function. Code details can be viewed in the help documentation. Here we have a simple demonstration. Copy the code, paste it into the panel of the event after page load, and change the component name. Preview the template. You can see the roaming animation is automatically played after the end of loading. That's all about 3D component.